constructing propositions from truth tables. So here is the idea. We are going to be looking at a truth table, first involving propositions P and Q, cases true, 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 false, false, true, false, false. And then we're going to have the outcome column. The question we want to answer is, what proposition involving P and Q should we use? We're looking for something that we can use, a proposition that we can use. For instance, suppose our outcomes are true, 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 false. What proposition? Let's find a proposition that gives this truth table. From basic logic, the audience will realize that this is the truth table for the disjunction of P and Q, P or Q. Let's try another one. Suppose your truth table is one that has outcomes true, false, false, false. Again, from basic logic, we recognize this as being the truth table for the conjunction P and Q. Now, let's take a look at this display right here. We're displaying here all possible outcomes for a truth table that involves propositions PQ. There are a total of 16 of them. Maybe all outcomes are true, in which case you would have a tautology. Maybe all outcomes are false, in which case you have a contradiction. Other cases, 3 are true and 1 is false. A total of 4 of those come up: true, 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 false, true, true, false, true, true, false, true, true, false, true, true, true. Other case is 2 trues, 2 false. True, true, false, false, true, false, true, false, and so on. There are a total of 6 of them. Another case, 1 true, 3 false. True, false, 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 true, false, 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 true, false, 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 true. So those are all our 16. Now our essential goal right now is to devise a method that will allow us to construct propositions that will produce any one of these outcomes. So let's give one a try. Our method, as will be displayed, will be one where the logic operators negation, conjunction, disjunction are involved. So let's illustrate. Let's try, for example, the outcome true, true, false, false. Let's say devise a method that will produce a proposition involving PQ and operators that come from this set of operators. Here's how we approach. We look at the outcomes. We're interested in creating a conjunction involving P and Q that will produce the true outcomes. So in this case, our first row and our second column have outcomes true. So we want to find out how to conjunct, how to create a conjunction that involves P and Q that produces a true outcome. So if you look at the first row, both P and Q are true. So if you want an outcome true with a conjunction, that will be P and Q, because true and true is true. For the second one, I want to use a conjunction involving P being true and Q being false. So we will have to say that P and the negation of Q are the only possibilities. Notice, you have true and the negation of false, which is true and true. That's how you can create that outcome of true. As far as the false are concerned, we do not deal with those. It's unnecessary, as the method will reveal after attempting it maybe a couple of times. Now, what we need to do is, in order to obtain a proposition involving PQ and the operators from the set that has negation, conjunction, disjunction, is we will take the disjunction of the two individual propositions that were constructed in this process. So I want the disjunction of P and Q, P and negation Q. Our claim is that this proposition right here does the job of producing this truth table. We can check. In the first case, true, true, excuse me, let me make a correction here. This is supposed to be P and Q. So please note that correction. So in the first case, where P is true and Q is true, notice that the first component gives a true. Or the second component will give false, because when you take true and the negation of true, you get true and false, which is false. As a result, true or false, which is true. So we have met our requirement. We wanted a true outcome, and we've got it. When P is true and Q is false, what happens? When P is true and Q is false, the first conjunction is false, but the second one is true, because that's how we made it so. What is false or true? True. As desired. That's what we wanted. So let's see. What about when P is false and Q is true? If P is false and Q is true, then you know P and Q will be false. Also, P and negation of Q will be false, because now we have false and negation of Q, which is false and false in this case. All it takes is one of them to be false, and we have it. What is false or false? Result false. As desired. Similarly, if both P, Q are false, P and Q is false. P and negation of Q is false, because you have false and true. That's false. As desired. So this technique right now has produced what we were hoping, a proposition that produces this truth table. So we'll enter it here. Now this is a partial result. Once we have a proposition, the next goal is to simplify the result if possible. So let's see, could we simplify the proposition P and Q or P negation Q? It's a little subtle to see how to simplify some logical propositions. In this particular case, it might take the audience a couple of overviews of the expression, and then realize, oh, this is a distribution. We're distributing P, Q, or negation Q. This is one of the distributive laws of logic. Now, for the next step, we notice that what's left inside the parenthesis must be true, because a proposition or its negation will always be true. If Q is true, then Q or negation Q is true. If Q is false, then you have false or true, which is still true. So that reduces or simplifies into P true. That's by the definition of the disjunction, definition of OR. And finally, when you have P and true, your result is P, because true is the identity of the conjunction. So by the conjunction identity. So as it turns out, our proposition, our simplified proposition will be P. Now, quick inspection reveals that that should be obvious, because that column, the outcome column, was actually identical to the P column. So we could start filling this in. The outcomes true, true, false, false. The proposition that gives that is P. Earlier we filled in that P or Q, true, 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 false. P or Q. We also did a P and Q, true, false, false, false. Now let's try another example. We are going to illustrate our method, the method where we construct a proposition that will give our desired truth table. Let's try the 8th column, true, false, false, true. We're after a proposition involving PQ and symbols from the set of operators, negation, conjunction, disjunction, that produce this truth table. Technique, again, what we do is we look at outcomes that are true and create conjunctions involving PQ that will produce it. Those are the two that we're concerned about, because those are the only two that give outcomes of true. So this one we already have seen that it takes P and Q. To get true, and when P, Q are false, then we're going to negate both. So we'll have to say negation of P and the negation of Q. Once we have these guys, all of them, we take the disjunction of them. So 4. In this case, there are two components. The first one is P and Q. And the second is negation of P and negation of Q. So we'll fill in our entry. So we have succeeded at finding a proposition whose truth table is that. Again, confirming this is just a matter of realizing that in these different cases of PQ, the only time that you're going to get truths are in these two cases. When P is true, Q is true. When P is false, Q is false. Any other case, true, false, what happens? When you have true, false, both of these get turned off, because to get this guy to be true, both have to be true. Well, that didn't happen here. Here both have to be false. That didn't happen here. Similarly, for the third case, false, true. So what happens is, the only case that you get this proposition to be true are the cases where we built this from. So in the first case, true, true, this guy is true, this guy is false. The result is true because true or false is true. In the last case, this guy gets turned off, is false, but this guy is on because of the way we constructed. So you have false or true, which is true. The other two cases, both are off, so you get false, false. Now, we're not going to attempt to simplify this. If the audience does try to simplify that, the realization will be that this is adequately simplified. So let's just record it as one of our columns, one of our truth tables. So we have P and Q, or negation of P and negation of Q. Now, let's observe, let's look at a couple more. Let's observe that the first column, which is a tautology, can be obtained if we are able to construct a proposition that turns out to be a tautology involving PQ. Also, let's observe that the 16th column, all false, requires you come up with a contradiction. So we would like to come up with a contradiction involving a PQ. Let's write down a couple of identities that will help in the endeavor. One of the identities is R, or negation R is logically equivalent to true. This is a basic identity of logic. Another one is R and its negation is logically equivalent to false. So I can employ this to get my tautology. All I have to do is say, okay, the negation or the proposition. Well, let's try P and Q. That's a quick way of constructing a proposition to give our first column. We want the last one, well, pretty much use that where R can be replaced by P and Q. So there we have it. This guy can be P and Q, and its negation, this will be P and Q, or its negation. Oh, let's try that again. Okay, so we can fill in the remaining columns with our technique. What I did in these two columns was actually not the technique. I just wanted to fill them in for this presentation. But the audience could construct these and those from our method. Our method is, again, we look at the outcomes. We only focus on the true outcomes. We construct constructions involving PQ that will produce those outcomes, and then those, you take the disjunction of them. Guaranteed you will get the proposition that will produce the truth table that you are looking at. Now, let's make one remark here. If you look at the 8th column, the one we constructed with our method, one of the ones that we constructed with our method, you will realize that those happen to be the truth table for P if and only if Q. That is the truth table of P if and only if Q. Our procedure has managed to establish that this will have to be logically equivalent to P and Q, or negation of P and negation of Q. So in having done that, we have expressed the biconditional in terms of operators from this set involving negation, conjunction, disjunction. So what that has done is the following. It's kind of interesting. Like we have in basic logic, we're introduced to the negation, the conjunction, the disjunction, the conditional, the biconditional, and the exclusive or. One of the facts of logic is that these logical operators will produce any proposition in logic, in binary logic that is. By us doing this, we have established that the operator biconditional, or if and only if, is redundant, because we can express anything involving that operator using operators from this set, negation, conjunction, disjunction. So in essence, we have reduced our set of operators that can produce propositions in logic. Now, one of the exercises for the audience is to do the same thing for the truth table of the conditional. The truth table of the conditional will look something like this. P implies Q. True, false, true, true. That's the truth table of the conditional. By applying our technique for constructing propositions from truth tables, the audience will come up with a proposition involving operators out of this set of negation, conjunction, disjunction that produce the same outcome. At that point, you have a way of expressing the conditional in terms of operators coming from the set negation, conjunction, disjunction, thus eliminating the conditional from being an operator that's necessary, or rather making it redundant. A similar exercise will establish that the exclusive OR is redundant. So that's an exercise for the audience to attempt to complete. Now let's bring forth one more example where we produce propositions for a given truth table. Excuse me, before that, let me also mention that the audience will be completing this table of outcomes. So we'll produce propositions for the remaining outcomes. There are 10 remaining outcomes for the audience to attempt. So one more example. Let's try this one right here. Now this one, in this example, we are going to illustrate our method for cases where we have three propositions P, Q, and R. Now our example right here is calling for a truth table that will produce true, true, false, true, false, true, true, true. Now the way in which we are writing our cases is right here. True, 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 false, true, false, true, false, true, 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 false, 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 true, false, 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 true, false, false, false. There is a pattern here in the exercise, in an exercise that will be given, the same pattern will be used. Again, in our method, what we do is we look at the outcomes that are true and use a conjunction. Now in this case, the conjunction that we're going to create will involve P, Q, and R. So that's the modification, that is the extension of the method. I want to create a conjunction involving P, Q, and R that produces an outcome true when P, Q, R are all true. I want a conjunction involving P, Q, and R to give true when the values of P, Q are true and the value of R is false. Similarly, in the remaining truths. So let's proceed. Very similar to what we did in our previous two examples. We're going to take conjunctions. In this case, well, all are true. So you could say P and Q and R. What about this second instance where you get outcome true? Well, you have P is true, Q is true, R is false. So it suffices say P and Q and the negation of R. Now let's go to the fourth outcome, which is true. We want the negation of P and the Q in the R. Let's go to the sixth one. Sixth outcome is true. Notice that again we're leaving the falses on process. We do not worry about false outcomes. We only worry about true outcomes. So in this case, the negation of P and Q and the negation of R for the seventh column, seventh row, negation P, negation Q, R. Negation P and negation Q and R. For the last row, all negations, so negation P and negation Q and negation R. Now once we have those conjunctions involving PQR that produce the true outcomes, then we will take the disjunction of them. So in this case I have to say P and Q in R, or P and Q in negation R, or negation P and Q and R, or negation P and Q and negation R, or negation P and negation Q and R, or negation P and negation Q and negation R. This proposition as a whole will produce this truth table right here. Now, we're not going to attempt to simplify this one. It is quite long and it will be a rather lengthy endeavor. It's not the purpose of our presentation. Now, for the audience, we will have an exercise where you will have three propositions P, Q, and R with these cases, and what you want is the proposition that will produce the truth table: true, false, true, false, true, false, true, false. Same technique, apply the same technique, and we will not expect a simplification of the answer. Simplification is optional. If somebody does simplify it, I would be interested in seeing the simplified version of that particular truth table. I believe this is all for now.